All right, it's recording. Shh. Thank you. Let's begin. 7G. So I already told you that your main aim, listening. Thank you. Thanks, team. Your main aim from chapter 7 was B, C, D. That was your 3 key skills. Then E was just an add-on. So B, C, D, make sure that is still consistently the skill that you're practicing. 7G should be the last thing that you do. If you haven't done B, C, D and you don't feel like you've mastered it, then don't do G. G is just notes for today. Yeah? So, when doing application worded questions, try to, and fill this in, it helps when you visualize the problem. Okay, so visualize the problem means that you draw it. So you can see in the first example, I actually copied a picture of a toy Hulk to illustrate the concept for you to think about, well, how would I actually model it and do it? Because most of us know the answer already. So if I just told you that there were 8 identical toys that you bought and you bought it for $24. So how much did each toy cost? Well, some of you probably can do that in your head and you got a general gist of how much each was. But if you bought 8 toys and it was $24 out of your pocket, then how much did each cost? You'd probably already figured out what you had to do. That's not the point. The point's not the answer. The point is, how do you model it? Okay, so how do you change that problem into an algebraic equation? That's the idea. Because that means when I give you more complex problems, you can then model it. That's the hard part. Yeah? So here, let's think about it this way. You got 8 identical toys. So I drew or copied 8 pictures. 1, 2, 3, 4, 5, 6, 7, 8. What we don't know at the moment is how much is it for one toy. So for one toy, one Hulk, how much is it is what I don't know. Okay, so I don't know. It could be $1, it could be $2, it could be $3. I don't know. So we then say, and this is what we normally do to model it, we say, well, let's say it was X dollars. Okay, just giving a number. So X is a number. I just don't know how much it is. If this is X dollars, that means the next Hulk toy is also X dollars. That means the next Hulk should also be X dollars. And that means all 8 of them, all those 8 toys, visually, you would say, well, it's X, 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 X. And if I asked you, well, if you bought all 8 toys, how would you normally calculate how much you spent? Well, what you would have figured out is you would have said, well, one toy plus a second toy plus a third toy plus a 4th, 5th, 6th, 7, 8. That's all 8 toys that I'm adding together to figure out the cost. Because if it was $2 each, you would have said 2 plus 2 plus 2 plus 2 plus 2. Or the easier way is, what's another way of writing X plus X plus X plus X 8 times? What's a shorter way? Yes, the nuke. 8x, because you got 8 of them. If I told you it was $2 each, you wouldn't sit there and go 2 plus 2 plus 2 plus 2 plus 2. You would actually just did 2 times 8. So same thing here. We could have just done 8 times x. But remember, how much did you spend at the end of the day? You spent a total of $24. So what you can see here is I'm modeling the situation by thinking about it. And I've got myself an equation. And what's the equation? It is 8x is equal to 24. That's the logic. Okay, so once you can create this, then you go back to what you've learnt in 7B, 7C. This is called a one-step equation. My goal is to find how much it is for one toy, which is X dollars. You don't want 8 of these toys. You just want to know what's the cost of one. Because 8 of them cost 24. How much is one? So how do I get rid of this 8? Going back to exercise 7B, how do I get rid of this 8? Let's go with the nuke. Yeah, because in between the X and the 8 is a times. And if you want to undo times 8, well, then the undoing process is divide 8. But whatever you do to one side, you have to do to the other. So logically, you probably figured this out in your head before, that X is equal to $3. That means each toy had to be $3 each, so that if you add them all together, it would have been 3 plus 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 3. That's the only way that you would have spent $24 if it's the same toy, same cost. Okay, so this is the idea. Each toy was clearly $3 each. Okay? $3 each. But how did I do it? I gave it a hypothetical number. I didn't know what that number was. I called it X. That is called modeling. And that's 7G. You won't be able to model or solve unless you model first. I'm not interested in the answer. Most of you already probably figured out it was $3 each. But I'm interested in the method. How did you get there? Because at the year 11 and year 10 level, what's hard for students is me trying to not tell them how to model it. They struggle to write an equation. It's not that they have trouble solving, because by the time you guys get to 9 and 10, you're better at solving. The problem is that you can't model it. So then there's no application. And that's why most students would say, well, when will I ever use this problem or skills? Well, you problem solve every day. If you had, I don't know, if you were earning, say if you work at Macca's, I don't know, how much, what's the going rate at the moment? Is it $14 per hour? 12, let's go with $12 per hour. Let's say you want to buy an iPad. I don't know, iPad's about what, $7.99 right now. And if I asked you, how many hours do you have to work if you only work, say, 6 hours a week, per week, and I asked you, how many weeks would you have to save to earn enough to buy an iPad? That is a typical linear equation problem. You can model that and solve how long. I can make it a bit more complicated and say, well, you're going to use your money. You earn $12 a week, and then you work 6 hours a week. Well, surely you would spend it. So if you spent, let's say, half of it every week, how long would you have to save now to make sure you buy an iPad? See, that's problem solving. I can model that and write it out as an equation, but that's why you guys don't see the benefit of thinking problem solving. You know, you ask me and I say, well, how is algebra useful? It's not the algebra. It's the thinking. It's the thinking of, well, how do I say, or you could just wing it. That's what most people in the population do. They wing it. They earn an X amount of money every year, and then they just spend whenever they feel like it. They go on holidays and all that, and they say, how much did I earn this year? How much have I saved? And they're like, oh man, paying mortgage is so hard. I can't pay off my mortgage. A lot of it is because they're not thinking. Same thing here. Okay, so we're teaching you to think. So let's do the next problem. Same thing, next problem. Let's say, Jamie and Lisa have a combined age of 48. So we know that together, their ages will add up to 48. But given that Lisa is 3 times, and this is where students find it confusing to understand, when we say Lisa is 3 times as old as Jamie, what does that mean? What does 3 times as old as Jamie mean? Because it's hard to sort of hear it and get it. It's easier to visualize. What does it mean that Lisa is 3 times as old as Jamie? Anyone want to go? Oh, yeah. Yeah, you're right. How old Jamie is?
How old Lisa's Jamie's 2 times
Oh,
old?
it's the other way around. And that's where it's tricky. So let's listen to and they're always going to word it like this all the way up to year 12. That's why it's important to understand. A lot of students do what Aria was saying, and that's very common, even teachers, and I have to fix them because it's how they word it. See, they say Lisa is. So if you write it out, this is where I'm saying visualizing it makes it easy. Lisa, so let's call it L for Lisa. So Lisa's age is, so I can say equals, so is, so equals to 3 times as old as whatever Jamie is. So that's where if Jamie was J years old, then Lisa is 3 times as old. Can you see how I'm putting it now? That makes it much more visual. And you can see that if Jamie was 10, how old would Lisa be? 30, because we said 3 times as older. Yeah, so it's like Lisa is 3 times as old as whatever Jamie was. So whatever Jamie is, Lisa's 3 times as old. So Lisa is 3 times whatever 10 is. So if Jamie was 5, Lisa would be 15. But to model that, well, it's just whatever J is, you times it by 3. So that's what I did there. I said whatever J was, times it by 3, and it should give you Lisa. This is what I mean by visualizing. Yeah, so when I teach my year 11s and 12s, I actually break it down like this. I say, what if they were 10? What if they were 15? And then I say, well, what if they were J years old? And then they can come up with this. But you have to be able to do that yourself without me guiding you. Yeah, so that's the skill. So here, this is our model. We've got now J times 3 will give you Lisa's age. What else do we also know? They said Jamie and Lisa, when you add them together, it is 48. So whatever Jamie is, however old Jamie is, plus however old Lisa is, that should give me a total of 48. So what I have now is I've got two different scenarios. I've got Jamie's age plus Lisa's age should be 48, but I also know Lisa is 3 times whatever Jamie's age is. So how do we solve it? And this is where some students will look at this and go, man, too many letters. I have no idea what's going on. And it's okay. That's the challenge. Okay, the challenge is to actually see it as numbers. Here's the trick. If you're there yet, here's the method. We know that Lisa is equivalent to J times 3. So why would we write J plus L when we can replace that L, so Lisa's age, we can replace it with 3 times J? Because we know Lisa's age is actually 3 times whatever J is, right? And J, so right now, can you see I've now changed the expression. Instead of J plus L, I'm saying, well, it's J plus 3 times J is equal to 48. Now, why do I do that? It's because you only got one person to figure out. It's much easier. If you got 2 people in the problem, it's too hard. If I asked you to split money between, say, if you got $10 between you two, so let's say Ariel and Arad. If we had $10 that we won from the lottery and I said, let's split it between you two, it's easy. 10 divided by 2 gives you 3. But then if I changed the problem, if I said, Ariel, you put in $2 to buy this lottery, Arad put in $1 to buy this lottery, and then Eric put in $2 to win this lottery, together, when we split it, it's unfair that the person that spent the most gets the equal amount as everyone else. So how would you split it? That becomes a harder problem. Yeah. So I'm trying to give you the idea that 2 letters is harder than 1 letter. We always like to keep it as 1. Yeah. So here, let's split it up. J plus, what's another way of writing 3 times J? 3J. So this is now 3J is equal to 48. And what you'll find is, this is very similar to what you've been doing in chapter 5. What's J plus 3J? 4J. Because that's the age. So whatever J was, if you add on another 3 groups of J's, you get a total of 4 of these J's is equal to 48. And then finally, I want to solve for J. I don't want 4 of these J's. What do? How do you get rid of this times 4? Divide by 4. And this is where you say, whatever you do one side, you do to the other. And so J must be how old? 12. 48 divided by 4 on the right gives you 12 years old. So this is what I mean. This is a problem-solving technique where you could sit there and trial and error. You can try to go, well, whatever Jamie's age is, Lisa's age, and you can kind of guess it. I could have done 10 and 30. 10 plus 30 doesn't give you 48. Then I might have tried something else. But that's my point. We're not in the game of guessing. There's a way to solve problems efficiently as long as you can model. So if J is 12, how old should Lisa be then? Yeah. It was 3 times whatever J was. So 3 times 12, 36. So Jamie must be 12 and Lisa must be 36. If you add the 2 together, it does give you 48. That's no guessing. We can problem solve. So the hardest part here is not the answer. It's this. Can you model it? That's the skill. Okay, so at year 8, year 9, year 10, it only gets more complex with the problems, but you start off a bit easier. Yeah, so please don't do trial and error. Trial and error is an older sort of skill that you learned in primary. We're now trying to use more sophisticated systems to solve. Okay? There you go. That's all for the notes for today. That's how you would do that problem. But again, don't do 7G unless you've done 7B, C, D, and then E as well. Okay? Skip F. G's last. Don't touch G unless you've done the basics. Here we go.